Okay, here's a quick video to help you if you're struggling with domain and range. So it's helpful to be able to visualize what the function looks like if you're given an equation. If you're given a graph, then you just have to look at it and decide what are all the possible values for x and what are all the possible values for y. Having an equation is much more difficult. So first we need to be able to recognize if we see a function like y equals x or f of x equals x, we know it's going to be a straight line. So it's going to be some kind of straight line, depending on what the exact equation looks like, if it's like 2x plus 1 or whatever. And mostly, unless they're like a horizontal or a vertical line, they're going to be, the domain and range is going to be all real numbers. So you would just write that as the domain. X is an element of the set of real numbers. So XER, you would just say, because X can be anything and so can range. So for the most part, like I said, unless you're dealing with a horizontal or a vertical line, in which case X and Y will have, yeah, it'll be slightly different, but I mean, you'll figure it out. Okay. Then if you see a function like f of x equals x squared, right away when you see that squared, you should recognize, oh, quadratic. And the most important thing for you to do is find the vertex, and that will help you find the domain and range. So that's the only thing that matters. Because hopefully you remember from grade 10 or 11 that the domain of a quadratic is always going to be XER. X can be anything. No matter where your vertex is, even if it was down here, even if it was upside down, these values are going to extend like out to the sides forever. So there's not going to be any restrictions on the domain unless somebody says them. And then the range, that's going to depend on your vertex. So the lowest point it can go in this graph is 0. So I would say y has to be greater than or equal to 0, such that y is a real number. I don't know if we have to say that or do we do a comma. I'm not really picky on the notation, obviously. And so depending on where your vertex is, if your vertex is here and then it goes down, well, that range is going to be y has to be less than or equal to -1. So really identifying the vertex is key. So if you have an equation in standard form, you're going to need to identify the vertex by putting it in vertex form or factored form and then finding the vertex. So you pretty much need the vertex. Okay, if you see an equation like f of x equals 1 over x, you know that's a reciprocal function, or sometimes called, do we call them rational functions too, I think, once you get to advanced functions, rational functions. So we've got the x in the denominator. So in this case, you're going to get like x and y can almost be anything, but you'll probably just have a restriction based on asymptotes. So just that guy I know is going to look like this. And I know it's going to have an asymptote rate on each axis. So I know if I wanted to say the domain, I would say that x cannot be equal to 0, but it's a real number. And then I would say range can't be equal to 0, but it is a real number still. And then just based on like how the equation changes, you need to find your asymptotes. So just a really quick asymptote review. The vertical asymptote is easy to find because that's the one where you just set your denominator equal to 0 to find out where its location is. So you can set your denominator equal to 0 to find your vertical asymptote. That's this one. To find your horizontal asymptote, I always just look at what are some really big and small values of x? What happens when x is big or small? What happens to y? That's what I do. So if I know if x was really gigantic, like if x was a trillion, 1 divided by a trillion is getting close to 0. So I just look at the extremes of x to find my horizontal asymptote. And finally, a radical function. F of x equals root x, so it kind of looks like this in some way. So you're going to need to find this guy. And then you can figure out your domain. So in this case, x has to be greater than or equal to 0. And x is a real number. And then for range, same thing, I guess. Y is greater than or equal to 0. And y is a real number. So depending on where that point is, if it starts up here, or if it goes like here, so have to find that location. And it'll just depend on what your equation looks like. So if you recall, like having a number out front, that's not going to affect this. That's just going to make it stretch. Or if you had like a number in front of the x, also not going to affect this location. But if you had something like x minus 1 under the bracket, where's that going to shift it? To the right one? And then if you have a number outside like plus 5, that's going to shift it up 5. So just remembering that kind of stuff from grade 11 math. And that's just your basics on domain and range. Oh, actually, one more thing. If you're looking at a graph, this is going to happen later in your math courses, probably. If you're looking at a graph and you need to identify domain and range, just one thing to keep in mind in case you don't know this, if you have line segments, like say you're looking at finding the domain of this line, a closed circle means it actually does go through that point. So if I wanted to describe this domain, that's -3, 1, 2, 3, 4, 5, 6. I would describe this domain as I would say this. So x is greater than or equal to -3 and less than or equal to 6. Whereas if, same question, but this time let's say is like an open circle. An open circle means it almost goes to 6, but it doesn't quite touch 6. So in that case, I would say it's greater than or equal to -3 and it's less than 6. I wouldn't say or equal to. And you can't say something like less than or equal to 5.9. You'd have to say 5.99999 and you'd have to never stop saying that. It's easier just to say less than 6. Sorry. And I think that's all. Yeah.